Hello scholars, welcome back to the channel. Today we're going to be doing simultaneous equations and we're going to be focusing on the elimination method. Now at this level there are typically two methods of solving simultaneous equations in algebra. There are other ways of solving it in other topics. So for example, we could solve them using matrices, we could solve them using graphs. Now in algebra there are two methods, the elimination method and the substitution method. Alright? So we're focusing today on elimination, and of course you know I'm going to also be doing a video on the substitution method. Alright, now remember I'm always telling you that you need to work with your dictionary when you're doing math, because the dictionary will help you to get the definition of the terms that are used, and most times the word as used in the English language helps in understanding the word as it is used in maths. Now there are a few cases where the word used in math is a total different meaning than the word used in the English language, at least the way it is used today, right? For example, calculus, different meaning than the one generally used in English language today, but maybe the origin was the same. But in most cases, the terms, they are derived from words that are used today in the English language, and the meaning will help you. Alright, give me 1 sec. Alright, so we're looking at the method of elimination. Now, we also need to know, what does the word simultaneous mean? Simultaneous, if you look for the word simultaneous in the English dictionary, it will tell you that it means occurring at the same time. So two or more events occurring at the same time. Why do we call them simultaneous equations? Well, for two reasons. One, we are solving two equations at the same time, and two, we are solving for two variables at the same time. So if you notice, each equation has two variables. Here we have an x and a y. X and a y. So at the end of our problem, by the time we have gotten a solution, actually two solutions, we have solved both equations and we have solved for both variables. And it doesn't have to be x and y, it can be any letter or any symbol used to represent the missing number, right? So we use a variable to represent them. We're solving two equations at the same time and solving for two variables. That's how we come up with simultaneous. Now, what does the word elimination mean? To eliminate something means to get rid of it or to put it aside, right? To get it out of the way. So in this method, we're actually going to isolate one of the two variables. We're going to get rid of it for the time being, really just put it to the side while we solve the other variable, and then we're going to bring it back and solve that one as well. Alright? Now in order to eliminate any one of the variables, we want to have the same coefficients in the pair so that we can either add or subtract to eliminate that variable. Right? So we're using the principle of the additive inverse. Bearing in mind, if you have a positive number and you subtract the same number, you will get 0. If you have a negative number and you add the same number, you will get 0. So those are additive inverses. That's the principle we're going to use. That's why we want to have the same coefficients. Now if you notice, for the first two sets of equations, we do have the same coefficients. Mark you, one is positive, one is negative, but the digits are what we're focusing on now. Here too we have the same coefficients. So I'm going to show you what to do for these, and then the last two equations, we will not have the same coefficients. So also you need to know what to do in that case. Alright, so let's look at the first two where the coefficients are pretty much the same except for the negative number, but we can work around that. Alright, so I like to draw a line under my original equation, so I'm just going to go through and do that. And I also like to number my equations. So this is equation number 1, equation number 2. Okay, number 1, number 2. So I'm just going to go through and do that for all of them, numbering the equations. Alright, so what we're going to try to do now is to eliminate one of the variables. Since the x variable has the coefficient of 3 and negative 3, we can eliminate those by simply adding the equations. So if the coefficients have different signs, if one is positive, one is negative, we add them to get 0 using the additive inverse property. If they are the same, if they are both positive or both negative, we would subtract the equations in order to eliminate that variable. So here we have 3 and negative 3. So we're going to add equation 1 and equation 2. When we add these, we get 0. 3 plus negative 3 gives 0, which is what we wanted to do in the first place, to eliminate the x. So now we add negative 4 plus 8, that gives 4y, and 10 plus negative 4, negative 14 is negative 4. So y is equal to negative 4 divided by 4, which is negative 1. So y is equal to negative 1. We're not done, and this is a common mistake that some students make. They solve for one of the variables and they forget that there's another variable that was eliminated that we need to go back for and solve for that, right? So we need to find x. So we go back to any one of the original equations. We're going to substitute this value for y. Now that we know y is negative 1, we're going to substitute it either here or here. So you choose the equation you want to work with. I want to work with equation 1. So I'm going to say, using equation 1, where y is negative 1, and I write out what equation 1 is, so that we are very clear what we're doing each step of the way. So we're going to plug in negative 1 here. Put a bracket and plug in negative 1. So that's 3x. Negative 4 times negative 1 is a positive 4. So now we're going to take 4 from both sides. And now we're going to divide both sides by 3. So x is 2. So our solution set then, x is 2 and y is negative 1. Now whenever we work simultaneous equations, it's always a good idea to plug back your values into both equations to see if they work, to see if they get the same answer. So if x is 2, 3, 2, 6, and y is negative 1, negative 4 times negative 1 is positive 4. 6 plus 4 gives 10. So that one clears. Negative 3 times 2 is negative 6. 8 times negative 1 is negative 8. Negative 6 minus 8 gives negative 40. So these answers check out, right? They are correct. We check them and we see they are correct. Alright, so here we have two of the same coefficients. They are both positive. So if we're dealing with both positive numbers, in order to eliminate them, we need to subtract. So we're going to subtract equation 1. Actually, I'm going to subtract equation 2 from equation 1. You could do either way. Either take 1 from 2, 2 from 1. It all depends on you. I prefer to take 2 from 1 because I have a smaller number here. So I'm subtracting the smaller from the bigger. But here we have a larger at the bottom anyway. So it really doesn't matter. You could take 1 from 2 as well. Alright, so 6x minus x, that's 5x. 2 minus 2 is 0, which we knew we were going to get that. That's what we wanted. We worked it so that we got that, right? We have eliminated the y. Negative 4 minus 6, that is negative 10. So x is negative 10 divided by 5, and that is negative 2. So we have solved for x. We're not done. We're not done. We need to solve for y as well. So we're going to plug in the value of negative 2 where x is either here or here. So I'm going to use equation 2. And I'm going to write where x is negative 2. So x plus 2y is 6. So I'm plugging in negative 2 here where x is. Now I'm going to add 2 to both sides. So I have 2y is equal to 6 plus 2. Now I'm going to divide both sides by 2. So y is 4. So my solution set, x is negative 2 and y is 4. Now let's quickly plug those in, substitute them into both equations, our original equations, and see if they work. So 6 times negative 2 is negative 12, 2 4 is 8, negative 12 plus 8 gives negative 4, negative 2, and 2 times 4, 8, negative 2 plus 8 gives 6. So they check out, these are correct. Alright, now like I told you, for this equation, this pair of equations, we don't have the same coefficient like what we had here or here. So we need to work it so that we need to manipulate the equations in such a way as to have the same coefficients so we can either add or subtract to eliminate that variable. So how do we get them to have the same, how do we get at least one pair to have the same coefficient? What we'll do is we're going to multiply the entire equation by one coefficient and this equation by the other coefficient. And you can actually use any of the pairs. So you can multiply all of this by 6 and all of that by 8, or all of this by 5 and all of that by 1. And you will end up with the same coefficient, and then we can go ahead and eliminate. So I'm going to choose this pair. So I'm going to multiply equation 1 by 5 and equation 2 by 1. So I'm going to end multiplying each of these coefficients by 5. I'm going to get 40x plus 5y is equal to 45. And that's a new equation, so I'm going to call it equation 3. If I multiply all of this equation by 1, I'm going to end up with the same equation because I'm multiplying by 1. And that's equation 4. Again, I draw my line because I have 2 new equations to work with. Do you realize that we now have the same coefficient? One pair of the variables have the same coefficient. So, all we need, since they are both positive, remember, if both signs are the same, we subtract. And if the signs are different, we add. So, the 2 signs are the same, they are both positive. We need to subtract them to get 0, to eliminate the variable, right? So, we're going to subtract equation 4 from equation 3. Again, you could do 3 from 4. Just bear in mind your negative signs. Just be careful with your negative sign. So I'm taking 4 from 3. So that's 40 take away negative 6. Right? 40 take away negative 6. When we're taking a negative from a negative, it's the same as adding. So 40 take away negative 6 is the same as saying 40 plus 6. So that's going to give me 46x. When we subtract 5 and 5, we know we eliminate the y's. That was our objective in the first place. We knew that was going to happen. So there is no longer a y. For now, we're putting it to the side. And 45 take away 22, that gives 23. So x is 23 divided by 46, which is a half. X is a half. We're not done. We need to find what is y. So we're going to substitute that half where x is. So I'm going to use, we can go back to the original equation. So I'm going to use equation 1, using equation 1. So that's 8x plus y is equal to 9. And I'm plugging in a half where x is. So 8 times a half plus y gives 9. Half of 8 is 4 plus y is 9. So y is equal to 9 minus 4, which is 5. So our solution set, x is a half and y is 5. Plugging them in, do they make sense? If x is a half, half of 8 is 4 plus 5, that's 9. Half of negative 6 is negative 3. 5 5 is 25. Negative 3 plus 25 gives 22. So we are correct. We are correct. Our solution set, x is a half, y is 5. So we have one pair of equations left to solve. This time it's just a little bit more complex. We actually will need to expand our bracket first. And we also notice that the terms are not really in the same order as these were. You notice the order that these were, we have one variable, another variable, and then the constant term is on the other side of the equal sign. We are going to need to get this equation in that form. So sometimes you will be given equations that are not in the form. Please be careful, make sure you put them in the format first, where you have one variable plus another variable plus or minus another variable equal to a constant term, and then you can use the method as shown here. So let us first expand the brackets and get the equations in the format that we want them. So for the first equation, we'll have negative 7x. We need the y to come over, so now it becomes minus 2y equal negative 5. That's our first equation. For the second equation, we need to expand the brackets. So 10 times x, that's 10x. 10 times 1/10, the 10s will cancel, and we'll have negative 1. However, we don't want the negative 1 here. We want it over there. So we're going to bring it across, and it's going to be a positive 1. And the negative 9y is going to come across and become a positive 9y. And that's our equation 2, right? So we expanded the bracket 10x. 10 times 1/10 is 1. So this negative 1, we're going to bring it over to the constant side, and it's going to become a positive 1. The negative 9y is going to come over as a positive 9y. So now it's in the format, and we're going to go ahead and solve. So we're multiplying this equation by 10, this equation by 7. So I'm going to have negative 70x minus 20y is equal to negative 50. That's equation 3. And 70x plus 63y is equal to 7. Alright, so now we have a negative 70x and a positive 70x we're going to add. So add equation 3 and 4. This cancels out. So negative 20y plus 63y. Alright, so that would give 63 minus 20, that is 43y. And negative 50 plus 7, that's negative 43. So y is equal to negative 43 divided by 43, that is negative 1. Now plugging in negative 1 in the original equation, so using y equal negative 7 in equation 1, plugging in this value here, negative 7x minus 2 times 7, alright, so negative 7x, negative 5 plus 14, alright, let me retrace my steps. So I'm using this equation, negative 7 minus 2y equal negative 5. Okay, so this is supposed to be, y is supposed to be 1. Okay, y is supposed to be negative 1. Alright, so 2, negative 2 times negative 1, that's positive 2. And when we bring it over here, it's going to become a negative 2. Alright, so negative 5 minus 2, that's negative 7. So x is negative 7 divided by 7, which gives us negative 1. So our solution set, x is negative 1 and y is also, x is positive 1 and y is negative 1. Alright, so we went back and we used this equation, plugging in the value of y is negative 1 here. Negative 2 times negative 1 is a positive 2. And when we bring it over, it becomes a negative 2. Negative 7x is equal to negative 7. So when we divide negative 7 by negative 7, we get a positive 1. So x is positive 1 and y is negative 1. Now, when we solve simultaneous linear equations, what we're actually doing is we're seeing, remember, linear equations would produce straight lines. So we're saying, if we draw two straight lines on the Cartesian plane, on the graph paper, if we draw two lines, we're actually seeing, so for example, if that's the Cartesian plane, and one line goes that way and another line goes this way, we're saying where the two lines overlap, we would take our x reading and our y reading, and that would be the solution of the equations. So when we get an x value and a y value, we're really saying if we were to plot these equations on graph paper, this is where the lines would overlap, where x is equal to that number and y is equal to that number. Okay, so that's it for solving simultaneous equations using the method of elimination. So I'm going to do a video using the method of substitution. So if you have benefited from this video, just drop a line to say thank you and share the video so others may benefit. And I'll see you in the next video.